Alright, in this next section, 7.5, we're going to talk about how we can identify proportional and non-proportional relationships. We've spent a lot of time looking at equivalent ratios, looking at graphs, all sorts of different things so far. And now we're going to view things kind of in context. And we're going to look at some tables and some graphs more in depth. Review these properties of proportional and non-proportional relationships. And again, we want to remember that a proportional relationship is basically saying that we have equivalent ratios. Equivalent ratios. So we're going to look first at tables to determine proportionality. Now we've got a situation here where we've got two jet ski companies. One is called Jet A and the other one is Jet B, and they rent jet skis. And if X represents the number of hours that you're going to rent the jet skis and Y represents the cost, it says find the ratio of Y to X. So remember, we put the vertical part, we put the Y part on top of the X part, the vertical over the horizontal, for Jet A and Jet B, and then answer the questions that follow. And remember, Y is Y on top and X on the bottom. Remember when we were drawing those triangles and we were figuring out the constant of proportionality, we were figuring out what's the vertical movement to get from one point to the other versus the horizontal movement. So that's going to be Y, and you're going to see more of that as we go on through this unit and I believe the next one as well. So anyway, let's go ahead and take a look at this. And it says here are the number of hours, so they declared the variables up here. X represents the number of hours that you're going to rent the jet skis, and the next column is the total cost, and then we want to figure out the ratio. So on this one right here, here's what we're going to do. We're going to take Y over X. So remember, X is the number of hours, Y is the cost, and that's going to be the same on both of these. We're going to do this kind of in a uniform fashion here. So we're going to put $75 over 1 hour, so that's going to be $75 per hour. $75 per hour. Alright, so we've got that one taken care of, and then we just go through and we do all of these the same way. So I'm going to do 120 divided by 2. I'm going to reduce that, so that's going to be $60 per hour. The next one is going to be 165 over 3, and if you do the math on that, it works out to be 55, so that's $55 per hour. 210 over 4, and I'm going to go ahead and write 255 over 5. So if we do the math on this one works out to be $52.50, $52.50 per hour. And then the last one, if we go ahead and do the division there, this works out to be $51 an hour, so $51 per hour. So we've got that one all filled out. Now let's run over here and take a look at this one. Now when we were going through this one right here, you'll notice that as we did this division, each one of these worked out to be a different amount, a different unit rate if you want to think of that. So on this one here, we're going to do 45 over 1. We're going to do 90 over 2, 135 over 3, 180 over 4, and then 225 over 5. So if I do this division, 45 over 1, of course, is $45 per hour. 90 over 2 turns out to be, once you reduce that, $45 per hour. 135 over 3. If you do the same thing, throw that into a calculator if you need to, but you get $45 per hour. And in fact, for each one of these, it works out to be $45 per hour. So I'm just going to go ahead and fill out each one of these. And again, if you need to verify that on a calculator, go right ahead. Alright, so we've got those filled out. Now I'm going to shrink this down just a tad, and then we're going to take a look at a couple of these questions. It says, how are the tables alike and how are they different? Let's deal with that first. So how are they alike? Well, if there are several ways where these are alike. You'll notice that they're measuring the same things. They're both jet skis. Okay. Alright, so jet ski companies, we could put that down. They're measuring the number of hours and the cost. Hours, cost. The cost isn't the same, but we're at least measuring that. And ratio, let's see, that would be the cost per hour. Let's see, any other similarities? There might be a whole bunch of them in here. Gosh, I don't even see any amounts that match up or anything like that. Now, how are they different? Well, the main way they're different is the ratios. Let's see, so we'll say cost per hour is different. Oh, one other way they're similar, they do both go up. The more hours you rent it, the more you're going to pay. That just kind of makes sense. And let's see, yeah, so this is a major difference right here, the cost per hour. This one is more expensive, looks like all the way through. So there are some ways that they're similar and they're different. There might be others. You can come up with some. With a class discussion, this usually turns out a little better with people giving their input and that sort of thing. Now the next question is interesting because it says which one is proportional, and this one should be pretty easy to see. There's some things that just jump out at you on these problems right here. Hopefully everybody recognize this is the one that's proportional right here. So jet B is the one that's going to be proportional, and the reason for that is they're all the same hourly rate. They're all equivalent fractions. So which one is proportional? We're going to write down jet B, and the reason it's proportional, I'm going to write this: same unit rate. I'm going to write down the $45 per hour. 45 per hour. Okay, I'll go ahead and circle that. And to put it another way, they are equivalent ratios, equivalent fractions. Okay. Now, hopefully you can see that when we do this ratio here, these are definitely different. The price is going down, really expensive to start, and then it gets cheaper. And then this one right here stays the same all the way through. So let's take a look at this and see if we can tell, without a context of a situation, without jet skis or anything like that, if we can tell which one's proportional. So on this one right here, this one says this table is proportional, and it says this one is not proportional, and then it says what about this table. So on this one we've got x is 2, y is 10, x is 4, y is 20, x is 6, y is 30, 8, 40, 10, 50. It says this one is proportional. Now there are a couple ways that you could tell this. We could do 10 over 2. We could do 20 over 4. You'll notice that in each case they work out to be 5, and you can do that with each one of these, especially this 50 over 10. That turns out to be 5. So it's almost like we can see our scale factor here is that we times by 5 every time. So this one is proportional. This one is not proportional, and we can tell by doing the same thing. We can do 10 over 1, so the unit rate here, or the reduced ratio, would just be a 10. And then on this one, if we do 30 over 2, we end up with 15. So those are not the same. So in other words, there's no scale factor that lets us go from one to the other. Like on this one we'd have to multiply by 10, on this one we'd have to multiply by 15, on this one we'd have to multiply by 20. So they're not the same ratio. Okay? So what about this table right here? I want you to take a look at that. So it says -2, that corresponds with -8 for y, -1 and -1, 1 and 1, 2 and 8, and 3 and 27. Well, you might have a guess there, but let's think about what we did here, and let's fill in this conclusion right here. It says to determine proportionality from a table, the ratio of, now remember how we do these ratios, we put the y over the x, so we're going to do the ratio of y to x must always be, now here it was always 5, and here it went from 10 to 15 to 20 and so forth, so it must always be the same in order for it to be proportional. Well, let's take a look at this one right here. Let's do -8 over -2. If we reduce that, we end up with a 4. Now all the other ones would have to be exactly the same if this is going to work out, so let's check and see. This is -1 over -1. That turns out to be a 1. So the answer on this one is going to be a big fat no, and you can check that on each one of these. All we have to do is see that one of the ratios is not the same. One of them doesn't turn out to be an equivalent fraction or the same unit rate, and then we can say no. So the answer on that one is a big no. All right, so that's how we can tell on a table, and this really is the big idea right here. Whoops. That really is the big idea, is knowing that if you're going to determine proportionality from a table, that the ratio of the y over the x has to be the same on every single one of them. Okay, so if we went through the first four and we got, say we got 4s for the unit rate or the ratio on each one of these, and then the last one was a 5 or a 2 or a -3 or something like that, it would be a no. It's got to be the same for every single one of them. Okay, now let's take a look at some graphs, and we're going to figure out proportionality from these graphs. So this is a similar situation, except for we're going to be renting different things. So we're going to be renting ATVs. So a Razor A and Razor B. They're both companies that rent these side-by-side ATVs. X represents hours, Y represents cost. Find the ratio of Y to X. So very similar to what we did before, but now it's represented in kind of a graphic form. And then use and answer the questions below. And again, we raise that question, why is y on the top and x on the bottom? Again, we're comparing the vertical movement with the horizontal movement. And we always do that when we're figuring out unit rates and looking at graphs like this. So I'm going to make this one a little bit smaller so things fit here. So I'm going to do something that we've done before. I'm going to go ahead and connect these points. I'm going to go ahead and draw that line, kind of straighten that out. Do the same thing on this one. And then like it said in the instructions, we're going to go through and we're going to find the ratio of y to x. So let's go ahead and compute each one of these, or figure out where each one of these is. The coordinates of this point are 0, 30. The coordinates of this point are 1 hour, and right in between 60 and 90 would be 75. So this is going to be 1, 75. This is going to be 2, 120, 3, and then right in between 150 and 180, that'd be 165. So that's going to be 3, 165, 4 and 210, and the next one would be 5, and if we follow that up right in between there, that'd be 255. Let's do the same thing with this one. This one's 0, 0. This one's 1, and then right in between 30 and 60 would be 45. So 1, 45, 2 and 90. Let's look at this one here. This would be 3, and then right in between there, that'd be 135. And then this one is 4 and 180, and this last one's going to be 5 and 225. Okay, now if we do the ratio for this one, this is going to be 30 over 0, which remember you can't divide by 0, so I'm going to write NA on that one. And then this one is going to be 75 over 1, so that's going to be $75 per hour. Go ahead and circle that one. 120 over 2, and I guess we could blow this up so it looks a little bit better. That's going to be $60 per hour. Let's make that look like we had before. 165 over 3. You'll remember that's $55 per hour. And when I say you'll remember, I'm hoping that you're seeing some similarities here. This is going to be 50 to 50 per hour. And then this one right here, 255 over 5 is going to be $51 per hour. Now, if I were to go through and do this one 0 over 0, that's not applicable. Okay, can't divide by 0. 45 over 1, 90 over 2, and I am hoping that everybody's got an idea of what's going on these problems right here, because on every one of these this is going to end up being $45 per hour. And I'm hoping that everybody sees that this problem is exactly the same as the one on the other side. The only difference is these people are renting Razors, and on the other side they were renting jet skis, but the pricing structure is the same. Okay, so how are the graphs alike? Well, they're straight. Okay, that helps. Let's see. They're both still doing hours and cost. They both go up. Oops, make that look like cost. They both go up, meaning from left to right they go up. How are they different? Well, they look very similar. Different numbers. And one of the big differences is you'll notice that this one right here starts at 30 where this one starts at 0. So right at the beginning there's like this $30 cost or whatever, okay? So we'll write razor A starts at $30, okay? Now, which one is proportional? Well, they both look very similar, but again, remember what proportional means. Proportional means that they're going to be equivalent ratios and that the y over x ratio, they're all going to be equivalent. And on this one right here, they are all different like they were on the other side. This is the one that's proportional, okay? So razor B is the one that's proportional. So this one right here is proportional, this one right here is not. Even though they look very similar, they both look like straight lines. In fact, they're kind of tilted up at the exact same angle. They go up by the same amount, the same rate each time. But this one starts at a different place than this one, okay? So what makes it proportional? What makes it a proportional relationship? Again, I'm going to write same unit rate for every single one of those, okay? But why aren't, if the lines look the same, why aren't these the same unit rate as those are? Okay, and that's really what we get into, and I'm not going to answer this last one until the end, because there's actually a second part of this and it's really important. So this graph is proportional and this one right here is not. You'll notice that they look almost identical. This one is proportional and this one is not. Okay, so I'm going to shrink this down so that we can take a look at this. So this is proportional and this is not proportional. This is and this is not. So let's take a look and see if we can figure out what's going on here. These two are proportional. These two are not proportional. Okay, so the way we tell whether or not it's proportional is we look at it and we say, okay, first of all, it's got to have the same unit rate. In other words, what that does is it makes sure that it's going up by the same amount every time. Okay, so it's got to be a straight line. So graphically, you'll remember that on the other side we said same unit rate, but graphically what that does is it makes it a straight line, okay? And the other thing is, these are straight lines. They're both straight lines. In fact, these two are both straight lines. The reason this one is not proportional is it doesn't go through 0, 0, okay? So to determine proportionality from the graph, the points must make a straight line, that's one thing, and go through 0, 0. They've got to go through what we call the origin. Okay, I'll put that in parentheses. They've got to go through the origin. Okay, go through the center, 0, 0. So this is a straight line, but it doesn't go through 0, 0. This is a straight line, and it does go through 0, 0. That's what makes it proportional. Straight line goes through the 0, 0, so that's why it's proportional. Straight line doesn't go through 0, 0. Now I've got an interesting example to finish up here. Take a look at this one right here. It says, what about this graph? Well, it goes through 0, 0, but it's not a straight line. So the answer to this one is a big fat nope. It would not be proportional. So again, to kind of review these ideas, if you're looking at a graph, the way you tell that it's proportional, again, you could go through and you could check all of these points like we did here, but you can just visually check and you can say, okay, is it a straight line and does it go through 0, 0? If that's true, then it's proportional like this one. If that's not true like the two of these, then it's not proportional. If we're looking at a table, then what we have to do is we have to determine what that y over x ratio is on each one of them. And then if they're all the same, every single one of them are the same, then it's going to be proportional. If even two of them are different, or if four of them are the same, one's different or something like that, all it's got to do is have one discrepancy, and then we say that it's not proportional. Okay, so on a table, we're looking for that y over x ratio to be exactly the same on every single one of them, and on a graph, we're looking for straight lines that go through the origin, and that's what you're looking for in each one of these.